Yo, what's up YouTube? This is my C++ Minecraft clone. And as always, for viewers that have just started the series, we'll do a summary so that you guys have enough context to start watching from here and do not need to watch all of the like hundreds of videos. And then chat, the early viewers on this stream will get to vote what we're going to do today. And in about 3 hours, we'll do a summary what happened during this stream. At the end of this stream, we'll do a summary what happened today. So let's start with the summary. What's up, LARP? What's up, Alex? What's up, what's up? Let's start with the summary. So in the previous stream, we added this village, and we had a problem where this block was above the ground. We couldn't change the terrain. But now off stream I managed to fix it. Now it's in the terrain as well. And we are spawning houses next to this road. And so this fountain is the center of the village, which from it the pathing starts from the center of the village. And so I just need to pick this point where this is going to be in the world, and it will automatically create these roads, and on the left and right sides it will create these houses. And that's what we did the previous stream. And in the previous streams before this one, we added like the player, we can move around, we have particles. Particles change texture depending on what block you break. We have the TNT, which we made to explode once you destroy it. And look at how it pushes the other TNT. And it's an actual entity. So it falls down. It falls down. We made it so it explodes once you break it. So that we could like put many TNTs all over the village. Like this. Let's... test them out real quick. It's pretty good. It's pretty good. Anything else that we did? Yeah, we have caves. We have caves, and we have what else? Yeah, cake. We have cake. This cake was for Detective Jones. I think today is actually his birthday. We're celebrating his birthday 3 days, man. Anything else? Think that kinda is. What's up, chat? I got a problem. Got limited, I can't chat in servers. What are you doing today, pets? You should add random seed. What's the goal today? Chat will decide. When you added caves, previous stream. Yeah, okay. I think this is kind of the summary. I think this is the summary. And so we can start brainstorming and voting what we're going to do in these 3 hours. Like every other stream. Like all the previous streams. Yeah, and adding this village creates a couple of new ideas we could do. So that's interesting. Like every feature we add, like the particles, it creates more ideas. So for example, like when we place a torch to have particles, or when a TNT explodes to have particles, like a little, like we got more and more ideas. Yeah, so let's start brainstorming. I'll open the notepad. Where we will start brainstorming, and I'll prepare chat here. Hello, chat. Random seed, Minecraft menu. Let's add, add menu, single player. Okay, let's start saving here ideas. So, like every time, I every time hope we add sounds. Maybe because I add it as a first option, I'll add it as a middle option. Because numbers like 17 and 20 win, so I'll push sounds a bit lower. I'll put here mobs. No, it should be, we have to be in order. Guys, when you propose an idea, it should be very specific. Because if I put here like mobs, nobody picks this. Nobody picks just mobs. So here let's do creeper. We can do villagers now. Let's put here fireworks. Let's put 3D Steve. Let's put ores. Let's put survival inventory. Let's put tools. Maybe to be specific. Tools and weapons. Anything else? Yeah, let's put sounds here. Anything else? Mountains. Oh, 3D noise. 3D noise. Frustum, Culling, more FPS, but that's more for off stream. Like last time, Frustum Culling almost won. I don't know how, man. I thought nobody would want Frustum Culling, but it almost won the last time. That was crazy, man. Lava and water. So they are static right now. We could make them into fluids. More particles. We could do structures. Yeah, so desert structure. We could do... What do you mean by a random world, Jen? What does that mean? Like, the world is pretty random right now. Oh, farming. Yeah, farming. Farming is good. We have pistons. Oh, iron golem. Oh yeah, iron golem. Yeah, that's interesting. Font. Use whole texture, shouldn't use part of it. We had just 3 hours for the particles. Like you can look at the village as well. The village is also not perfect. Oh, the sulfur cubes. Every time you open the game in random. Oh yeah. It's not like it's fine like it is right now. Like this will be very easy, man. We just need to change the seed every time. The seed is just a number. Like this is like a 5-minute work. Like it's intentionally the same world every time. Oh yeah, item drop and right hand to hold item. Anything else? More food, what do you mean? We could do heart and food system. We can do... No, I hate phantoms. Herobrine is not in Minecraft. Let's focus on stuff that's in Minecraft. I'll open Minecraft in the background. Open Minecraft. Oh yeah, enchanting. Hello, Blocky. What's up? We need Minecraft as a reference. Just to borrow inspiration. Wood types. We have oak and spruce. Like, how many more wood types do we need? I'll put Herobrine. I'll put him here and let's see what chat decides. But I don't know what we're going to do here. Like, man, like... creepers. We have creepers here. Actual mining. Can you tell me what you added, please? Ender Dragon. Ender Dragon will be difficult. Oh yeah, weather. So snow and rain. Horses. Okay, whatever you say, chat. Whatever you say. Enderman. Cows. Hey, Pets, what's up, Frost? Fishing. Anything else, chat? Pigs. Oh yeah, nether. Dent. Fish. Bee. Uh, bro. Focus, guys. Focus. The goat. Okay, the goat. Bro, nobody will vote for the goat. Or else it will be just a meme vote and the whole stream we're just adding a vote. Goat. Oh, what's up? Yeah, you're not banned. What's up, Sushi? Don't post any more links to like weird links. Maze. Is there a maze in Minecraft? What do you mean a maze? The hippo, maze, bird, spear. Oh yeah, the spear. Bro, application, if you time out somebody, like, that's very... like, you know what happens. Yes, there's a maze. Like, don't abuse your power, application. How does bro not know what a maze is? Yeah, I know what a maze is. But does Minecraft has a maze? Oh, I'm in the older version. Yeah, I'm in a... Oh, shield. Shield? But we cannot test the shield because we don't have mobs. Like, we will need some kind of a projectile against us. Ability to go to the far lands. I don't know how to create the far lands. Potions. Potions is interesting. Potions. Yeah, that's an interesting idea. Ender pearls. Sword tools. Has been recommending. What do you mean? What do you mean? Skeletons. Fine, we can add skeletons. We can add skeletons. Anything else, chat? Elytra. Is this the wings where you can fly with? Is that the wings? Rails. Oh yeah, minecart. And boat. Adding a boat. Maybe a new biome. Offhand. We don't have a main hand, Blocky. we don't have a main hand. Imagine the first hand we add is the offhand. Command block. Command block. Chat commands, because we have a chat. Zombie. Anything else, chat? Nether. Oh yeah, the ghasts. The nether ghasts. That can actually like be a pet, I think, recently. The trident. I'm not sure. Oh, the dog. The dog. The dog. Like dogs. Dogs. The dogs are cool. Oh, main menu. Main menu. Settings. Nobody votes for settings. Settings have been here in the options many times. Nobody picks it. The sniffer, bro. Glowstone. What are you doing today? Chat will decide. Experience. Torch. You Linux in the past. Yeah, I've used Linux. Parrot, main menu. Profiler. Yeah, profiler in F3. That would be helpful. Profiler. Isometric screenshots. Oh, from the beta versions. Isometric. Okay, let's do that. Isometric world screenshot. That would be interesting. What else, guys? You are very creative. The lantern. Mods and resource. Bro, you're crazy. That would be so... That in 3 hours, I cannot even do an MVP. Jukebox storyline. Bro, I'm just a one guy. The build city or spawn. Oh, I bet we could... I think profile is way too early for now. No, it's the perfect time. Shaders. We already attempted shaders in 2 streams and failed. We couldn't manage to do it. Oh, nighttime. Oh yeah, day and night. Nighttime. Yeah, nighttime. 3D clouds. 3D clouds. Story mode, optimization. Okay, 50. Okay, last one, last idea. Hopper, rain. Yeah, we have it in the weather. Nether portal. Yeah, we have the nether portal as a here in an option. Spawn egg. We don't have mobs. Okay, let's put the hopper, but nobody will pick the hopper. We have the menu as an option. Okay, let's put the hopper and whatever happens. Nobody will vote for this. And chat will prove me wrong. Okay, chat. Let me prepare the poll, but I need to pop out chat. And here to create a poll, what are we going to do? And chat, now here we have how many options? We have 53 options and we need to pick 4 options. So guys, start typing numbers and I'll pick 4 numbers from here. And don't spam them because you'll get LARP, you'll get like banned. Don't spam it, LARP. Don't spam your vote because you get banned. Okay, we have 17, 24, 8, 10. Okay, we have 22. We have what else do we have? And don't spam them because that would be bad for you. 2, did we have 2 before? No. Yeah, 22 we have. 50, 22, yeah, 22 we have. 11, oh yeah, I saw many times 11. Anything else that repeats? 49, 5, bro. 4, 51, yeah, 51, okay, 51, one last option. Oh, 7, we have 7 repeating. Yeah, we have 4 options, guys. Starting the poll. So, chat, where's the poll? Do you guys see the poll? Oh, okay, here is the poll. Okay, so chat is voting now what we're going to do. So, the options are these ones. 22, what's 22? 22 is Hero, bro. Why did you add Hero, Brian? 11 is Frustum Culling. How does Frustum Culling always get included? And 51 is nighttime. Nighttime will lose. And 7 is where's 7? Tools and weapons. So chat, what are you going to pick? We're going to whatever chat you pick, that's what we're going to do today for 3 hours. And like I will not be able to fully implement it. I'll do my best, like minimum viable product. Minimum viable product. Like with the particles, when chat voted for the particles, we just did the block breaking particles because they are particles for other cases as well. So like whatever you pick, just so you know, it's impossible to fully implement it. Petsa, if next stream someone asks for multiplayer, you can do it. Bro, multiplayer will be impossible. Okay, right now it's kinda a tie between Hero Brian and what? And Frustum Culling. Bro, why is there so much interest in Frustum Culling? 51, what was 51? Nighttime. Yeah, nobody cares about nighttime. And 7 is tools and weapons. And so as of now, most people have voted for Frustum Culling and Hero Brian. That's what most people have voted for. Let's see what wins. I have no idea what will win. Let's see who wins. Yeah, okay, chat, we're going to end it. We're going to end it, chat. Like, we're ending it in 3, 2, 1. Chat, we're ending. We're ending it. I'm ending. I'm ending it. I'm ending it. Okay, what won? What's the winner? The winner is 11, which is Frustum Culling more FPS. Bro, chat, do you realize Frustum Culling will be mostly coding? Like in 30 minutes, there'll be nobody here in 30 minutes. Like, we'll just be coding here. Okay, chat voted what we're going to do. Competition was between Hero Brian, Frustum Culling, and Nighttime, and Tools and Weapons, I think. And the winner was Frustum Culling. And so that's what we're going to add today. We're going to add Frustum Culling. Ideas 8. Let's save this. Oh, bro. This will be impossible. I have no idea how to implement Frustum Culling. I just added it as an option. But I have a vague idea in Frustum Culling. Here is what I know what Frustum Culling is. The first thing that I know is it will increase the FPS. Let's see how much. Let's compare the FPS difference between my C++ clone and the Minecraft Java clone. Let's compare the FPS. Because Frustum Culling, if we implement it properly, we should get a boost, a big boost in FPS. In order to have the FPS showing, let's open up MSI Afterburner. And we need to also remove the limiter for the FPS, because I've set it to be like around 160. We need to remove the limiter in the FPS. So it was like vsync, something like that. Vsync here. Okay, now I've removed the FPS limit. Let's see how much FPS we get. Whatever FPS we get now, this is the target to beat. At the end of the stream, we need to get more FPS than whatever we get now. We need to wait for the entire world to generate, because the world generation is on the main thread, which means that it tanks the FPS. First, the world needs to generate, and we'll see how much the FPS is. And chat, as you can see, we're in a big need of an optimization, because we're at around 100 FPS. And for some reason it's going, oh, because we're generating the caves, probably. Because of the caves. Okay, let's say we're about 100 FPS. And when we're going even lower. That's extremely bad, because we are running on a very strong computer. If I am getting this low FPS, that means you guys will get like 15 FPS. That's why chat picked Frustum Culling, to improve the FPS. Let's see how much FPS does Minecraft get. Let's see how much FPS Minecraft gets. Minecraft, oh, it's limited here. I think it's limited. How can I check? Performance, maybe? I don't see performance. Oh, max frame rate, unlimited. Unlimited. So Java is beating us, chat. Java is beating my C++ clone. It's at 400, 4 times the FPS is Java. 4 times the FPS. Are we here in... So, and chat has voted Frustum Culling. What is Frustum Culling? In my understanding, Frustum Culling is basically like, look at how you have terrain all over the player. And every block that we need the game renders, every block that the game draws, like this one, it lowers the FPS. Like this is, everybody knows it. If you increase the render distance, here if you increase the render distance, the FPS lowers. Like right now it's 300. If we go much more, it will lower. It should lower. Yeah, it lowers to 200 and 100. Yeah, it like we are 2 times less FPS. And look at this. This is Frustum culling. Look at how now we get this world. Frustum culling basically makes it so we keep the render distance, but we don't render blocks that are not visible. So let's bring back the render distance. Let's bring back the render distance. So guys, you basically saw that the more blocks we need to render, the lower FPS we get. Like that's the main issue. And so Frustum culling makes it so we can keep the render distance, but for example, the chunks behind me, we don't need to render them. And so by ignoring these chunks, like right now, if you noticed, we just generated them. If we ignore the chunks behind us, we'll get more FPS. But if we're like from way above, here we're rendering everything. And here, look at how the FPS dropped. It's like my FPS, 100 FPS. And why is that? Because Frustum culling cannot activate here. There is no terrain behind me. Here we are looking at the entire world. And this is the worst case situation, which basically the player will never end up in. And so in my game, I'm doing the same. I'm rendering everything. Even here, down here, the caves as well. Like I'm rendering all of these caves. This tanks my FPS a lot. And so basically, we need to make it so we draw here on the screen only what's visible. That's what chat has voted. And I have avoided adding this because we need math. And whenever we need math, I cannot do anything about it. But chat has voted it and we need to figure something out. We have a time limit of 3 hours. And so we should be able to at least increase the FPS in any possible way. So chat, we need to decide how are we going to tackle this. Yeah, let's go in creative mode. Let's go to the ground. And chat, what are your expectations for adding Frustum culling? Do you think I can do it? In my understanding, Frustum culling is not rendering blocks outside of your Frustum. Yeah, the camera. Do you have and yeah, let's tell you what the Frustum is. So if we go on the internet in here, camera Frustum images is this. This is the camera Frustum. So basically, this is here in this like box here is anything that's visible to the player. This is what we're seeing, and outside of it, we have chunks that we're rendering, and that lowers the FPS. We just need to, we're using math to calculate if a chunk is outside of this Frustum and to not render it, and this will drastically boost the FPS. Do you have triangle only debug mode for rendering? Would be cool to see. I think Raylib and OpenGL offers it. We are never going to add greedy meshing. Bro, I miss so much chat. Hey, I saw a video with Bog and you. Yeah, nice. Frustum culling only renders what is in the camera Frustum. Tomorrow we are running Herobrine. Don't. You have to change present mode. What do you mean? So much RAM application. to what? Tomorrow we adding multiplayer. How deep are the chunks? The chunks are like just like in the Minecraft, like 256 something. Do corner check. Are you not doing that on we are doing everything on the main thread. I don't have multi-threading. Tomorrow is for... Oh, we forgot to add world saving as an option. I'm using subchunks. So a subchunk is 16 by 16 by 16. And this 256Y height is a chunk. Make an option to make Minecraft only use determined RAM. I'm watching the... Bro. Yeah, no, I'm not doing VSync. Which VSync limits the FPS to be the same as the refresh rate. Turn off VSync. Yeah, I've turned it off. Video settings. Do have triangle. Okay, yeah, greedy meshing. We're never going to do that because Minecraft doesn't use greedy meshing. Does the game have culling? Yes, it has culling. It has culling. Just Frustum culling. That's easy, man, just based on the FOV. Bro, it's easy for somebody that knows how to do it. It's not easy for me. I have no idea how to check if a chunk is outside of the Frustum. But we have 3 hours to figure something out. And we can start with something very simple. Even if it's stupid or wrong, that's perfect. It's totally fine. The only goal is to get more than 100 FPS. If we get 200 or 300 FPS, that's a win. It's also based on the resolution aspect ratio. What do you mean? Maybe put stuff on the stack and not the heap, and make sure you don't get stack overflow. Yeah, but isn't the stack very limited, extremely limited? Like it doesn't have gigabytes, I think. Does the game render the underside of blocks if sides are covered? No, we have culling, You could simply implement ray tracing, and that's not... Bro, we're not doing ray tracing. We do a sphere check inside camera Frustum with trigonometry and check if the block is under Frustum. I'll save your suggestion for later. Why not greedy meshing? I think it's just ABB test for each Frustum plane. Really? I'll save your suggestion as well. Scully draw. Let's save your suggestion. And who else suggested? Yeah, you. You think it's just AABB. So this AABB is axis aligned. Like I'm using it for the collision checks. It's a very simple algorithm which just checks for if a point is inside of a like cube with certain position and dimensions, or like if 2 cubes are colliding. I'm using it for collision. So this viewer is suggesting to use AAB for the Frustum culling, but we'll see. Make MIP map. We have MIP map. Once I read what you guys have said, we'll start implementing it. Are you adding settings? Not today. Why not do Minecraft? You need whiteboard. We have Excalibur. Also, will we handle a case where a chunk below the surface gets cut, or we'll just do Frustum without? Yeah, we'll keep it as simple as possible. If we have time, we'll try to do more fancy stuff. Relink memory. I'm using the heap. Load only requires stuff into memory. Add LOD. No, we're not doing level of detail for meshes and chunks because Minecraft doesn't do it, and it looks like a bit ugly when you look at it at a distance. I think stack is 1 megabyte. Since the chunks go up to the world space, you can simply simplify the problem to 2D for the main chunks first on the X and Z. That's a good idea. You could also do the AB just extended. Switch Y and Z axis so that the Z is height. There is no reason for that to be right. We'll make village. Just extra confusion. Hi, bro. Hi, you are talking with a really serious accent. Where are you from? I'm from Bulgaria. Okay, let's do this. Let's do this. And by let's do this, I mean let's decide from where to start and how to simplify the problem. So let's go like every time whenever we have a goal to implement a feature, we go to Minecraft. We go to Minecraft to get some references, to get some reference. So Frustum culling. We will be Frustum culling the chunks. These are the borders of the chunk. This is one chunk. Look at how it goes from the world height to the absolute bottom. And this chunk is visible. We are rendering it because it's visible to us. We are seeing it. And we are always seeing it because like we are inside of it. But if we go like this, right now that chunk behind us is gone. It's not rendering. Only if we look at it, now it's rendering. It should be something like that. And look at how now we get 600 FPS because we are looking at the single chunk. Look at how it's 600 FPS. And if you look at the more chunks we look at, the lower the FPS gets. That's basically the trade-off of Frustum culling. Look at how it's 600, now it's 500. Now it's 400. Now it's 300. 100. Look at how it lowers and lowers the more chunks we see. We need to figure out what's the algorithm for this. It doesn't need to be exact. We just need to make it be close enough. Just like with the villages. Look at how the villages here are much prettier. Look at how much prettier the villages are here. Like you have multiple houses, the roads can go to the left and right, and in 3 hours, like this is what we managed to do. And it will be the same with Frustum culling. We will not be able to get like 600 FPS, but if we manage to get like 300, that's a big win. We'll use the FPS as the measure of how we are doing. That's what we're going to use. How do you already have anything ready? What do you mean? Would maybe try C++ with make chunks cubes instead of the default cuboid. I had seen it add more performance. The way that comes to mind, for each chunk, calculate the angle to the camera for each corner of the chunk. If any of them is between the lines created by the camera Frustum in 2D, then include them. You can look in the key bindings in the debug section. It should be there somewhere. If the player is looking down, then use multiple triangles. Most of the comments didn't make sense. Let's try to see what's like chat. Some of your suggestions are very good and some of you probably like got it right, but I want to do it differently. I want to like fail because that's how I learn. I fail, and when it doesn't work, I have the aha moment, and that's when the learning comes. Like it's extremely important for me to do it badly and fail, and I think that's better in the long term instead of like chat suggesting a technique and doing that. So instead of like reading chat, I want to think of what's the simplest possible approach we can do just by like using the absolute basics of what Frustum culling is. So basically, if we simplify it the most, what's Frustum culling? Basically, the main, well, it's solving a problem. It's a technique to solve a problem. And the problem is we are rendering everything. And we don't need to render everything because that lowers the FPS. Like, so I have an idea. We could do it a lot simpler. We could try to just not render what's behind the player. Like here. But that's maybe not a good idea because like what we did here. Like this terrain is behind us, but now it needs to be visible. So we need to ignore the player position. We just need to focus on where the player is looking. So this is one thing that we learned. Anything else that we can think of? If we try to use this here, what can we get from here? What can we get from here? From this image? Oh, it's even leading to this website, Learn OpenGL. This is very good website to learn OpenGL. Like I've personally went through the getting started section. That's how I started working on the Minecraft clone. But I stopped after the getting started section. We will not read this article. I just want to look at the image. This is the frustum of the camera. We need to check if a sub-chunk or a chunk is outside of it. Before we can do that, we need to get this. And this is just a few planes. This plane, which is called the near plane, and this plane, which is called the far plane. Is it possible to ignore these other ones and just focus, like, to start with one single plane? Like here, whatever is behind the near plane, to not render it. Can we do that? Yeah, because in the game here, the near plane is basically right around where the player is. And so all of the chunks behind it, we can just ignore them. And if it's like this, now we are rendering everything. Yeah, we can just do this. Okay, I have an idea. This is the plan, guys. This is the plan. We'll try to get the frustum, and especially to get this part of the camera. This part, this plane. We'll get this plane. And we'll try to check if a chunk is behind it, and to not draw it, and to see what improvement we have on the FPS. And if it's not that much, we'll add one more plane, the far plane. That's what I'm thinking to do. And chat, what's up? Mm, 7 days is probably enough. Definitely success, double approach, make it. I've good luck, man. Hope bro, I just muted you. Sorry, man. I'll unmute you later. You became wholesome and I muted you. Sorry, man. Now don't look at images. Pick up a pen. Start with just near plane frustum. Yeah, that's what we're going to do. You need to get near and far plane from Raylib camera. Yeah, that's what we're going to do. Those planes are constructed with trigonometry. Also, are you calling the draw functions? Are you iterating over all chunks? Or are you using an indirect draw call? I'm not using indirect draw call. Bro, I'm just using Raylib. And Raylib is a wrapper around OpenGL. Like Raylib simplifies everything. I got jump scared by the possibility of math the moment I opened the stream. Yeah. Sadly. Yo, what's up? What are you going to make today? Yeah, today we're adding Frustum culling, which should basically boost the FPS. We are potentially going to triple the FPS. Because right now, Java is beating us. Look at how Java right now is 300 FPS. And my game, with a much lower render distance, is 100 FPS. Like, look at how short our render distance is. Like, I just noticed it. And compare it to the original. Look at the original. Like, this is much bigger render distance, and they get triple the render distance. So, this is the motivation for Frustum culling. Let's now start doing it. Okay, this is the goal. We need to focus only on the camera, where we're looking. Why? Because here, the first idea was to render only the chunks in front of us, all of the chunks in front of us, and to ignore the chunks behind us. But if we use just the position and the player looks down from above, that's wrong. Because now we are looking at chunks behind us, and we will not be rendering them. So that's why we will focus only on this. the Frustum, where the player is looking. And we need to see how we can get this from Raylib. So let's just search Raylib camera Frustum. Let's see how we can get access to it. Is there an example for this? Yeah, look at this GIF. Look at this GIF. This here, the red, it's pretty hard to see, but this is the Frustum. This is where the player is looking at. And here, this is orthographic, I think. And this is perspective. Yeah, this is perspective. And this right here is the near plane. This is what we want. I want to not render the chunks behind this one. Can we show controls? I want to make a screenshot. Yeah, like this. And we'll go in Excali draw. Here. Right here, this is the near plane. This is the near plane. And if a chunk is behind it, like let's say just a block is behind it, we don't want to render it. That's what we're going to focus on. I think this will simplify the most. And let's see if there is an example for this, for Raylib. Because Raylib has lots of examples. Raylib has lots of examples for all kinds of situations. If they have one for Frustum culling, that would be the best. Frustum, what's this? Assets. Main.odin. I have no idea what Odin is. I think it's a programming language. Maybe here. This thing. Yeah, that's just the GIF. What's this? Get Frustum planes. What's this? I have no idea what this is. I think GLM, this is a library for math. But we're using Raylib. Raylib doesn't use GLM. This is a math library. Anything else here? Like currently, the goal is to get this plane, this one. And that's what I'm searching for, how to get this plane. Maybe from here we can find something like that. Here they do it in the shader, which is a program like the vertex shader, fragment shader. Shaders are programs that run on the GPU. So I'm not sure, chat, should we be doing this on the GPU? I think it should be on the CPU. Because like if it's on the GPU, we will have to like draw the chunk. And I want to filter them out before the draw call. So I think it should be the CPU. Yeah. Frustum culling should be done on CPU. Yeah, it should be on the CPU. So how to get the Frustum in the CPU? Because here they create a shader. Bounding volume. Oh, yeah, this is the AABB, access aligned. This is what I do for collisions in Minecraft. We could do a simpler one, a sphere. So to pick the chunk origin, if we're using subchunks, we can get the subchunk origin and do a sphere around it, like just a radius. But if we're using a chunk, I don't think we'll need to use a sphere, actually. We have many possibilities here. Camera information just of chunk boundaries plus point. Yeah, but here's what's the problem. Like you guys are saying, I just need the camera information. But the problem is here in Raylib, where is the camera? Here, if I create a camera, 3D camera, and if we look at the camera just has position, a target, up direction, the FOV, and if it's if it's a perspective or orthographic. That's what the camera has in Raylib. It doesn't have Frustum. It doesn't have anything else. I would need from this information to get it. But there was an example in Raylib for cameras, Raylib camera 3D. There was an example which was filled with a lot of useful functions. Yeah, when we did camera update, like update camera, this function is from Raylib, and inside of it, it has a lot of helpful functions. This is in our camera header. Here, do they have anything about the Frustum? No, but they have other helpful functions. Yeah, they get the camera forward, get the camera right. This is extremely useful. Camera yaw, camera pitch, camera roll, camera view matrix, and projection matrix. Maybe this can be useful as well. Just use the X and Y for target and FOV. You should render a little more than Frustum, because if you move camera too fast, it will not render. Yeah, so a buffer, to add a buffer. Yeah, that's helpful. Thank you, man. Think you might be able to use FOV to deduce the near plane, maybe. Get camera projection matrix. The projection matrix. Oh, I thought you only made videos. That is it. Question, currently learning C++. Any recommendations on optimal pathways on learning? I'm not the best person to ask. I just start working on projects, that's it. Like, is that really the case? If it's done per frame, then it shouldn't be a problem to turn fast. You need forward and rights. You get Frustum faces from clip matrix, basically projection and view matrix. You have to create Frustum from the camera axis. So we got a couple of suggestions. One viewer said I need the camera projection, and another viewer said I can do it with the camera forward, up and right. So if we go back to the image, here, let's look at the image. Here, the camera, like if we remove these ones, for this camera, here is the forward, here is the right, this is the right, and this is the camera up. This is it. So how would I get all of this from this? Oh, I could just with the forward, I could with the camera position and the camera forward, I could probably have, oh yeah, okay. Guys, look at this. How to define 3D plane. I remember in university, in geometry classes, you could define a plane with equation. With an equation, like with a point. Like you can define a line with 2 points, right? And you can define a plane with 3 points. You can define a plane with 3 points, but here we have something else. Here we have a position and a vector. We have a position and a vector. Define a plane with position and vector. Can we do that? Is this it? Vectors. Yeah, here usually we just need 3 points. Oh, a normal vector. Yeah, we can say that this is the normal vector. So basically the normal vector is like here. If we have let's say this is the plane in 2D view, a normal vector is like, it comes like this. It's like here it's 90 degrees. It's 90 degrees. So we could say this camera forward is the normal of this near plane. So we can change our terminology. Define plane with position and normal. Can we do that? Why can a plane be defined with its normal line? Plane? Yeah, here they talk about the normal. Here, what is chat saying? You get Frustum faces from clip matrix. Oh. You have to create Frustum from the camera axis. View projection nearest plane on a unit cube equals near plane. Do you think... Bro. View projection. View projection. Oh, these are the... yeah, but this is just the upward axis. This is the right axis. This is the... this is just 0, 0. Should give you the 3 points you need. Oh, so you're saying like the 3 points of the plane. Ah, I get it. But we can... okay, we have two options. What Jake is saying, to get the 3 points of a plane, like to define the near plane with 3 points using this. And we can... and the other strategy is what another viewer suggested from clip matrix. I'll highlight his message and then I'll show you something. Yeah, here. You get Frustum faces from clip matrix. So what is that? So if we go in learn OpenGL, and here if we search for camera, I think that's where, or like coordinate system. Coordinate system. If it decides to load. Yeah, I think it's in coordinate systems, but it needs to load. Learn OpenGL coordinate system. Yeah, it should be here. Okay, now it's working. Now it's working. Test. Okay, have internet. So, what are these world spaces that chat is talking about? This is local space, this is world, this is view, and this is clip. So basically chat is saying that we can get the Frustum from here, from clip space. And we can get just the matrix. And what's the matrix? Well, the model matrix just transforms like the model positions from local space to world space. That's what the matrix does. Like you just give it, like you just multiply a position, which is a vector 3, like 0, 0. You multiply a position with model matrix and it goes from local to world space. And that's what the matrices do. So like we could create a matrix that takes a position and moves it like into clip space. But chat is saying the matrix itself is enough. And so here in the code we saw Raylib offers functions, these functions, get camera view matrix and get camera projection matrix. We can get these two matrices and multiply them. To multiply them so that we can get the clip space matrix? Question mark. Chat, does this, is this, am I right, chat? Laser 2, oh yeah, thank you man, that will be helpful. Just direction though, it's a unit vector. That's what I need, the normal is enough. The view matrix adds position. That's the unit matrix he needs. If he wants to build the plane with normal plus position, then he needs the inverse. Oh, you lost me here. The inverse forward vector of the camera and not the vector from the unit cube because it won't use matrices. When you place TNT on road, dirt gets placed inside dirt. Yeah, I know, man, I know. I would recommend to not do through clip matrix. Also, how are you handling chunk modifications? Do you remesh the whole chunk? Yeah, the whole, no, just a sub chunk. So 16 by 16 by 16 region. Would your project be possible with Python? Probably. Inverse forward. I'm confusion. Well, chat, you picked Frustum Culling. Obviously Frustum Culling will be confusing. If it's confusing for me, it will be confusing for everybody. Like the confusion is infectious. But chat, do you know that confusion is the best indicator that you're learning something? Like it's an indication that learning is happening when you're confused. So if we don't give up, we'll have an aha moment, and that's when you're learning something. So it will be a bit painful short term, but it will be worth it if we push through. And we just need to use what we currently know. We don't need to read any tutorials and articles. Let's just experiment and play around. Even if we don't get a satisfying result, it's fine. Like the world will not end. So let's focus, guys. Let's focus. This should be very simple. This should be very simple. We just want this near plane. We just want this plane. So we can define a plane. We can define it with 3 points. Here, for example, this point, and this point. We'll use this chat suggestion. That's what we'll use. We'll use this suggestion. Hopefully this will give us 3 points in this plane. And here he says to multiply these three positions with view and projection, which we have all of the components. We have the view and we have the projection. So basically from here, the position starts from here. Like one of the position the viewer suggested is 0, 0. So 0, 0 starts from here. Model matrix is nothing, it's the identity. We move here, it's still 0, 0. And then the view matrix. This depends where the camera is. And then like after we multiply it, then it's here. Then it's not 0, 0, it's a different position. Then we multiply it by projection matrix. And now we're in clip space. And so chat is saying the position we get here will be in this plane. This plane here. This plane. That's what he suggesting. Mr. Jake, why when we multiply these positions with the view and projection, we are getting a point here? Like, are we actually getting a point here? We'll test it out, and while we are doing it, hopefully Jake will reply. Like, why did you pick 0, 0, 0, 1, 0, and 1, 0, 0? Like, isn't the position of the camera important? Or is the position like applied in these matrices? But let's do this. Let's try this. But let me think about it actually. Because, okay, let's say that it works and we get this plane. But what's after that? What's next? Well, the goal is to not render some chunks, those that are not visible. That's the goal. And so basically, we'll keep it simple. We'll do a simple check. Just a point in space. And we'll use subchunks, not chunks. So a subchunk is a region of 16 by 16 by 16. And the subchunk has an origin, where that subchunk is, which is a point in space. And so basically, we'll do one simple check. Is the point in space behind the camera, like this plane, or in front of it? That's what we're going to do. So we have 2 steps we need to achieve. First step is to define this plane, which will use just 3 points. And then we'll go over all of the subchunks positions, and those positions that are behind this plane, we'll ignore them. And where does the ignoring happen? The ignoring happens when we're rendering. So in the game layer, where we render, on render here. And here I go over all of the subchunks here. And so here we draw the subchunk, and here we can do the check. And here we have a position. like a subchunk position. We should have a position in the subchunk. Yeah, here, subchunk origin. So here we need to check if subchunk origin is behind Frustum near plane, like this. Or like if it's in front of it, here, and we'll draw it. If it's in front of it, we'll draw the subchunk. Else, we'll not draw it. Very simple. And we'll see if this boosts the FPS. Hopefully, we'll get some kind of boost in FPS. But let's get this Frustum near plane. Let's get it. Let's comment this out. And let's see, did Jake reply anything? Jake. I think I made a mistake. Perfect. It's very well that I asked you. What is... can you show how it looks? I missed the intro. What are you working on? Frustum Culling? I at least understood a few things in stream. I think it's referring to different axes. New and just started C++. Hello, what has happened so far? I'm mostly just yapping, but we are pretty near to testing some code. We are very near to test some code and see if we can get a big boost in FPS. You need also far plane. We're keeping it simple and easy. Let's just do the near plane. First, it's too late for me. Wait, I'm confused. Can you tell me what is happening? Trojan? What exactly are you confused with? I think I made a mistake. Jake, I'm thinking. And Jake is the viewer that gave us the suggestion how to get the near plane. I'm thinking about it, and the view matrix would convert it into screen space, but you want the 3 points in world space. That's what I'm saying. Discussing how we want to add Frustum Culling. Jake saying something is not right alert. I'm confused myself. How? I think I might be wrong. Okay, it's not a problem, Jake. We'll figure something out. Already working. Are you working on? Oh, yeah, we're Trojan. Basically, we're trying to triple the FPS. We're trying to triple the FPS. I once wrote a bit of code because Java has more FPS than us, and we're using C++. And Java has a garbage collector. Like, we should have a lot more FPS. When multiplayer test with viewers, I'm not confused anymore. You gave me my answer a little bit ago. Hey, what's up? Near normal is clip column 3 plus column 2. Near normal. But we already have it with the camera forward. The near normal here. We want this plane because we want to check before we draw a subchunk. We need to check if it's behind the camera. This is the camera. And this is where the camera is looking towards. It's looking at this block. We want to check before we draw a subchunk. We want to check if it's visible, like this block, or if it's not visible. And we'll check it if it's just behind or in front of this plane. And we need to check that. Okay, let's start from there. How do we check if if a point is behind or in front of a plane? How do we check that? Check if point is behind plane. How do we do that? I don't want you. Check which side of a plane points are on. There are basically two sides. We need to check in which side it is. Here what it is, plane. he takes cross product of these two vectors to get the normal vector. We already have a normal vector. The normal vector is this, the camera forward, which basically normal vector is like here, let's say this is the plane. Normal vector is just like a regular vector with a length of 1 that is like 90 degrees towards the plane. That's how you get lighting with these normal vectors. Every plane has a vector like this. So if the plane was like this, then the normal vector will be like this. This will be the normal vector. So it's always like perpendicular. English is not my first language. I don't know if that's what you call it in English, but I think it's like perpendicular. And with a length of 1. This should be 1. Should be 1. So we already have the near vector. Okay, this is what he does. Equation to determine your plane. And he determines the plane with 3 points. With 3 points. And here you need to substitute x, y, and z coordinates into the left-hand side of the equation. Yeah, here. And look at the sign of the result. Oh yeah, that's very easy. Points having the same sign or on the same side of the plane. Honestly, I did not examine the details what you wrote. So basically what this guy is saying in Stack Overflow, which nobody uses anymore since you have ChatGPT, he's saying we need this equation. We need this equation, which is basically, this defines the plane. So we need this of this plane. Of this plane. We need that. We need that. Are we gonna check using 3? No, it's fine. We're not doing like that much optimization. We're keeping it simple. If your FOV is 120, then 3x is the absolute best you can get. Java being faster than C++ is not good. Have you even debugged to see what's taking most of the frame time? No, the goal is Frustum culling. Like the goal, chat decided to add Frustum culling. Like it's fine. We're not changing the goal. A dot product, you could rotate it so it matches an axis. Just checking if it's less than it. It's perpendicular. Height 2 times distance. Bro, I don't know what this is. For real, get ABCD from position and minus forward vector. Yeah, okay. How can we get this? How can we get this? How can we get this? So this is where we are at currently. Inside of the game, like here, this is Minecraft. And like this is one chunk. This is one chunk. And it has like 16 sub-chunks inside of it. So in my game, I just go over all of the sub-chunks. And I draw them, all of them. I draw all of them. And drawing, the more sub-chunks we draw, the less FPS we get. And in the best case scenario, if we don't draw anything. Here, if I remove all of the sub-chunks and I don't draw anything, here I need to not draw the semi-transparent ones as well. If we don't draw anything, we'll get a lot more FPS. Let's see how much FPS boost we get by not drawing anything. 180, bro. We're not drawing anything. Can we get one? Oh, bro. We're oh, we're cooked. Chat, we're cooked. We're cooked, chat. We're not drawing anything and we're extremely limited. Bro, we're cooked. Oh, okay, it's fine. Now it's 1000. Okay, chat, it's fine, it's fine, it's fine, it's fine, it's fine. It's fine. Because we're running everything on the main thread, temporarily the FPS lowers. Temporarily. But now it's fine. 1000 FPS. Look at this. When we do not draw anything, we have 1000 FPS. We have 1000 FPS when we don't draw anything. But that's like unplayable. We still need to draw something. This is one maximum. Like this is the one extreme, not drawing anything. The other extreme is drawing everything. But when we draw everything, we get a lot lower FPS. We get a lot lower FPS. Like here, a lot lower FPS. In the 100s. It will stay like that, it will not improve. It's not like the other example when it jumped to 1000. Here it will stay at around 100. Like this is the two extremes. And Frustum culling makes it possible to be in between stage by adding this if conditional. And here we're in an in-between stage where some subchunks are drawn and others are not. And which are drawn? We are drawing only those that we can see, basically. Only those that we can see. So here, only those we can see. Like this one. And to determine if we can see it or not, we will use this plane, which is part of the camera frustum, which is this thing. And how we need to check, I'll just check one point here. Let's say this is the subchunk. Let's say this is 16 by 16 by 16, and it has an origin. Let's say it's in the center. So it's just a point. We'll simplify it as a point. And so basically to check if we are seeing this, so that we know that we need to draw it. To check this, we basically just need to check if this point is visible to the camera. So my check will be if it's like towards this side of this plane. If it's like here, it will not be visible. So basically we need to check if it's to the left or to the right to this plane. And how are we going to do that? Well, in Stack Overflow, we saw a simple check, this one. We just, in this equation, we just replace the x, y, and z with the position of the point here. We'll take the point here, we'll take the subchunk origin, and place it here in this formula. And this guy says that we just need to look at the sign. We just need to look at the sign. Depending on the result, we'll know if it's visible or not. We'll do the check here. And so here, if it's visible to the camera, we'll draw it. Else, we'll not draw it, and we'll get a boost in FPS. Hopefully, 3 times the FPS. Hopefully. And in order, like, we need this equation. And how are we going to get it? Here, this x, y, and z is the position of the point. We have these values. But we don't have the A, B, C, and D. We don't have them. We need to calculate them from the camera. And so basically, if we have 3 points, like this point, and this point, we'll be able to calculate this equation. And we'll be done. And we'll be ready. And the time limit for today is 3 hours. It's 3 hours. So, and we're 1 hour in. So we have 2 hours to figure out how to get this equation. So we need to decide how to get this A, B, C, and D. The information we have is the camera forward, which I'll assume is the normal of the plane, and we have the camera position. We need to check on the internet from those values how to get this equation. That's it. That's the plan, chat. That's the plan. I think that's a good plan. Wait until we get multi-threading working. Hey, how are you doing this fine Sunday? Good. I got math textbook and it says x where ABC is the normal vector. Oh, ABC is the normal vector. XYZ is the positions probably. If you substitute the position of the into XYZ, then you can calculate D. If you substitute the position of the point into x, y, z, then you can calculate d. Yeah, but what point should I pick for x, y, and z to get d? Yeah, what point should I use for x, y, and z? But that's a good idea, thank you. Have you? Oh yeah, the camera position, right? The camera position. Yeah, if we place the camera position here, and A, B, and C to be the vector normal, we should be able to get the D. Bro. Why did I say like that? Are you setting the seat? It's constant every time. I might have a silly question. Do you create a model if the subchunk is empty? No. I don't think he's adding LODs. Hello, it's Hiragana. Yo, what's up, Hiragana, man? How are you? I'm good. Won't that call only 50% at most? Then we'll look at the other planes as well. But we'll keep it simple with just the near plane. I think min-max of chunk will be better than origin. Can you explain, not sure what it is? It's best to go back in the stream. Because we said it multiple times and we need to progress. I think you can find those in the English alphabet. Show render. Okay, nice. This is distance from camera origin to Frustum. I mean, it's offset. Distance from camera origin to Frustum. Position. Position plus forward times near. The normal is minus forward. What is this? Position. The camera position. So this is just a point. And we add to the point forward multiplied the near distance. So the result will be just a point. We need this equation, the A, B, C, and D. We need this equation, not a position, right? If the normal vector is positive towards the camera, then it's visible, no. If the normal vector positive towards the camera, why not use RenderDoc for performance profiling? Can RenderDoc have? Does RenderDoc have a profiler? Mr. Task, the goal is to add Frustum culling. Don't worry about it. That's the goal. If you are checking just for behind, then I think even the center of the chunk is accurate enough. Since the near plane is so tiny, it probably doesn't matter if it's the point of the camera instead of the point on the near plane, but it might. No. I want the equation for the plane. It doesn't matter how small the near plane is. Do we know the distance between the camera eye point and the near plane? We do know the direction. We'll just use, let's say it's like 0. We'll use the camera position, it's fine. And we'll play around with it, with the distance. We'll see what it's actually used, but we can start with the 0 distance. Position is the camera position. Forward is the vector returned by that function. The near distance is the near distance fed into the perspective matrix. Should be defined somewhere. The near distance will be something like, anyway. Bro, I'm making my own Minecraft clone in Python. Okay, let's do an attempt. Okay, let's do this. Here, let's use this. Let's try to do this. So here, the A, B, and C will be the normal vector coordinates. X, Y, and Z will be the camera position. That's how we'll get this D value. And in calculating those, the A, B, and C, and D will have this equation to check if a subchunk is visible or not. That's it. And we're just using this near plane, but there are others as well. There are other planes. There are other planes here. Well, we're just using the near one. just so we can simplify it, and because I think that would be the simplest thing to do right now. But we need to use this plane as well, this plane as well, this plane as well, to be completely sure it's here, because the chunk could be here and it will still say it's visible, but it's actually not. And so we can optimize it even more. But just checking if it's behind this or in front of it is enough. It's completely enough. Just as a first attempt. Okay, let's try to get the goal, current goal. The current goal is to get this equation. We need this. We need this. So we need to get A, B, and C, and one viewer said that the normal is the A, B, and C. So we just need this to calculate. We just need this. Let's attempt to do it. Let's attempt to do it. And let's print it out in the debug menu here. I'll start the game and show you the debug menu. But let's remove this. Let's start it. A dot product. Here, but let's remove the profiler, the FPS counter. Let's remove the FPS here. Okay, perfect. So here on the top left is the debug menu. Here I'll print information about the camera. I'll print it here. I'll print it here. And let's draw the water as well temporarily. Currently, what are we drawing? Currently, we're drawing the camera position, I think. Yeah, currently we have the player position. We can change it to the camera position, but let's output these values, the A, B, C, and let's calculate the D, and let's output them here. Let's output them here in the debug menu. Let's do that. Let's do that. Let's do that. So where are we going to do that? We are going to do it here. Yeah, here, player position. This is the debug information. Let's do camera position. Camera position. This is the camera position. And here, get player camera. Oh yeah, this is the player position. Oh no, this is actually the camera position. Okay, it's fine. So here I want the A, B, C, and D. And there will be floats, probably. There will be floats. There will be floats. There will be floats. And so what now? So let's calculate them here. So float A. This will be B, C, and D. So let's get the forward, the camera forward. How are we going to get it? There was a function for that here. There was a function for that. Get camera forward. Let's use this. Let's use this. And here vector3 cam forward equals this. And this is world get player camera, like this. Get player camera, and here let's include our camera. And here this needs to be pointer. Sure. And what chat is saying, A is cam forward X. Maybe we need to multiply it by -1, but we'll see. Cam forward Y. Cam forward Z. And here we need to calculate this. So we'll calculate it by... this is camera position. Let's rename it. Cam position. Camera position. And here we calculate this by A. How did you suggest doing it? It's A times here. A times camera position X plus B times camera position Y plus Z times camera position Z. This should be C. Okay, this should be it. And here let's draw them. Let's draw them here. So A, B, C, D. Perfect. And let's see, do we get any kind of result? We need these floats for the equation, this equation. Let's see if we're getting any kind of result. And then we'll see the next steps. We'll see the next steps. What's the issue? Here the issue is with the printing, probably. Yeah, here with the printing. What's the issue? Yeah, here I want floats. Yeah, here I want a string, it's this string. Then I want 3 floats, which is these floats. Oh, yeah. Here I want the string and then this. Yeah, the order was wrong, but now it should be fine. Let's see, do we get 4 floats? Okay, we get 4 floats. And look at this, they change depending on where we're looking. They change depending on where we're looking. Perfect. And now what? Now let's pick one chunk. Let's pick one subchunk. And let's test it if it's visible or not. And like, to print it out here on the debug. To print it out on the debug menu on the top left. So we could pick, for example, this chunk here. And to check if it's visible or not to the camera Frustum. And to output a boolean. We need to pick one subchunk. Here, what's our position? Yeah, let's pick like 0, 0. Yeah, somewhere around here. This is positive Z, this is negative Z. So 0, 0 on the X and Z is around here. Or we can actually pick the fountain, here, the fountain. Because we already have its position saved. Okay, let's check if the fountain is visible. So this is the code. If we're like this, we should get true. If we're like this, it should be false. If we manage to do this properly, we will have Frustum culling. And we are like an hour and a half in. We are like half an hour and a half more of time. So we're very good on the progress of time. Here let's do a boolean. Boolean is fountain visible. And here by default, let's say false. But here we need to do the equation. We need a position. What's the fountain position? Where's the fountain position? Yeah, here. Where is it? Position, vector 3, spawn location 10 on the X, 20. Yeah, we need to get it from here. Where are we? Where is this? This is in the update. Sure, fine. It's in the update. It's at a separate place. Yeah, we're not saving the position. Let's save the fountain position. Because we start at world height and we go down until we see terrain. Let's save the fountain position. Position details, fountain position. Like this. And here, what do we do? And here... spawn point. Okay, let's do fountain position equals Let's copy the spawn point of the fountain. Spawn point like this. Perfect. Now we have the position. Now we have the position, and let's check with our equation if it's visible or not. Let's do that here. If it's visible or not, let's do it here. Here, the fountain position. Okay. How are we going to do that? We have this equation. We have the A, B, C, and D. So let's calculate it. We'll get a number. We'll get a number. So let's calculate it. Here, let's calculate it as a float. Equals A times fountain position X. Let's use the block origin X. And then plus B times fountain position Y plus, it's block origin Y, then plus, then the C times fountain position block origin Z, and then plus D, like this, plus D. And so we should get a number. Sure. Yeah, we substitute X, Y, and Z with the coordinates of the point. Sure. And let's see what the point is as a result. Let's see what the point is. Where are we going to implement it? Here, let's say. And how are we going to call it? Equation result equals the float. And we'll add it here. We'll add it here. Let's see. And let's test it out. Let's see what number do we get depending on where we're looking. Depending on where we're looking. Okay, right now we get negative number. Okay. And it's still negative. What if we look like this? Oh, now it's positive. So they said to look at the sign. To look at the sign. Yeah, okay. So, and this is the point here, right around here is the point actually. Right around here is the spawn point. It should be around here, the spawn point. And so when we look above, it's positive. When we look at it, or like below, it's negative. So, are we doing it correctly? We could make some changes here, the forward, like a viewer suggested to inverse it, the forward. So by -1, like a vector 3 scale by -1. And let's see what difference does that make to the final number. And we'll use this final number to determine if we should draw the subchunk or not. It will be our indication if it's visible or not. So it should be here. Okay, negative. And we're looking at it, it's positive. And here it's positive as well. It should be behind us right now. And let's say negative, it's not visible. And now it's telling it's visible. Visible. Still visible. Only when we look up, it's not visible. Only when we look up, it's negative. Oh, we could here D to be here to multiply with -1 as well. -1. Like this. And let's test it again. Let's see what changes. We're testing if the fountain is visible or not. It's because we're using the equation. If it's like this and it's not visible, then we don't need to render it and we'll get a big FPS boost. That's what we're doing. So now it's positive, now it's negative, now it's positive. So when it's positive, it's not visible. And now it's visible when it's negative. Yeah, now it's... Oh, I think this is it actually. I think this is it. Yeah, when it's negative, it's visible. When it's negative, it's visible. Yeah, let's do this. Oh, let's do this. Let's do this. Let's do this. Let's do this. Let's do it. Let me think about it. Oh, this A, B, C, and D, we need to calculate them once. We need to calculate them once. And this will be calculated for every subchunk. And if it's negative, if negative, it's visible. So if it's positive, we don't draw it. If test is positive, do not draw. We'll do something like that. Okay, chat. I think that's it. I think I think once we test this, it will look very well. Chat, what did I miss? Minus D on the float? Yeah, we did minus D. We did minus D. Inverted, yeah, we did minus D. What are you doing, Petsy? We're adding Frustum culling. I think you need minus, yeah, I'm doing minus D. Other one is a game similar to Minecraft. What you're adding? The goal is to add Frustum culling, which should boost the FPS 3 times. It's not on GitHub. Please listen to that one chatter that seems to know math. Yeah, like we're listening to him. I think it works. Just inverse it. It's working. That works. It's backwards, but it works. So we have to just remove the inverse of the camera forward for it to be positive visible. Ah, okay. We can do that as well. We can do that. Here. Okay, done. So now if it's positive, it's visible. Sure. Let's see it. This is the fountain. It's positive, it's visible. And now it's negative, it's not visible. Here, visible, not visible. Perfect. Yeah, perfect. Okay, guys. Okay. So let's do one quick summary and we'll attempt to implement this for all of the subchunks. And we should get a boost of FPS if we do it correctly. If we manage to do it correctly. So chat decided today that we should add Frustum culling. So put very shortly and simply, we're drawing everything. And the more stuff you draw, the lower the FPS is. And if we don't draw anything, we'll have 1000 FPS. Right now we have around 100 FPS when drawing everything. We have like less than 100 when we draw everything. And if we draw nothing, it will be 1000. We need some kind of a middle ground. Frustum culling will give us this middle ground. And what we managed to do is, like here, this fountain. We managed through code to calculate if this is visible or not. And so basically what we're going to do right now is, if a subchunk, which is 16 by 16 by 16 blocks, if it's not visible, to not render it, which should give us a big FPS boost. And so let's do that. Let's do that because we need the FPS boost, because with C++ we're getting 100 and Minecraft Java is 300 here. It's 300. Here, look at how we get 300 in Java. But if we look like here down here, it's like 600. This is Frustum culling. And even 700, because most of the chunks are not visible and Minecraft is not rendering them. But if we look here from above, almost all of them are visible, and so the FPS tanks a lot. This is Frustum culling to 100. Look at how the FPS tanked. This is what we're adding. And we're like almost there. We're almost there. And let's try to implement it. We're almost there. Let's try to implement it. So basically we need just these values. We just need these values. Let's get them here. Let's copy them. Let's how are we going to do this actually? Okay, let's go when we draw all of the subchunks. Here on draw. Where is it? Where do we draw? We draw here on render. And here we go over all of the subchunks here. So here, let's calculate the A, B, C, and D. And here, let's get the... Oh, we need the camera forward. My bad. We need camera forward, which should be in game layer. Should be here, right? So let's calculate it. Nice. Okay, perfect. And so we need this float value. This is the equation that determines if the subchunk is visible or not. And it needs the subchunk position. It needs the Okay, we can just do it here. We can do it here. We can do it here. We can basically do it here. Yeah, it's fine, it's fine, it's fine, it's fine. So if... near plane equation. So if near plane equation is positive, it's visible, and we will draw it. And we'll draw it. Here, we'll draw it. Like this. Else, we'll not draw it. And that's how we'll get the FPS boost. That's how we'll get it. And we need to do it the same for the semi-transparent ones. We need to do it the same here. But here we need to use the subchunk origin. Vector3 position equals iterator second origin, like this. And here we do position X, Y, and Z, like this. Perfect. And let's copy this and do it for the semi-transparent ones. Like this. Like this. Yeah, okay. So let's test the chat. Let's test it. Let's see if we get an FPS boost. Let's see if we get an FPS boost. Yeah, we don't need the vector3 scale, sure. Like I left it there temporarily, if we want to change the scale to inverse it or not. Okay, let's test it. We had around 100 FPS. Let's test it how much we have now, but chat, you need to know that we need to wait for the terrain to generate, since everything is happening on the main thread. We need to... Oh! I think some... Yeah, look at how... Yeah, look at how we get... These ones are not rendering. We need to add a buffer a bit. We need to add a buffer. But it's kind of working. It's kind of working. So everything behind me should not be rendering. Everything behind me. But let's wait. Let's wait for the whole terrain to render. We need to wait for everything to generate. We need to wait for a bit of a boost. Oh, if it's greater or equal than 0. Yeah, you're right. You're right. But we need to wait, chat. Because when we didn't... Oh, look at it. 200. Bro. Bro, 200 FPS. Like almost 300. Almost 300. Yo, chat. Chat. Bro. 200 FPS. Like almost 300. That's a big boost, actually. That's a huge boost. Like 270. We got a huge boost, chat. 270. And chat, you need to, like before it was around 100. And like we doubled the FPS. We doubled the FPS. The corners of checker overlap, so you could probably reuse the chunks there. Do you think it's possible to copy GTA your way? No. Focusing on... Yeah, chat, we are focusing on redstone. Bro, look at this, 270 FPS. 270. Chat, all of this was possible because of Jake. Like, let's thank Jake. Like, Jake helped us a lot. Let's put W Jake. W Jake. Thank you, Jake. You doubled our FPS. You doubled our FPS. But I'm not moving right now because once we move, the terrain will start generating and it will tank the FPS. If we move, terrain will start generating. Like here, we start moving, terrain will start generating and it will tank. Yeah, it tanks the FPS, the terrain generation. For this, we need multi-threading. We need multi-threading to not tank the FPS. We need multi-threading to not tank it. Yeah, this is something different. But once everything generates, we get 200 FPS. And we need to fix this. We need to fix this. But bro, this is like kinda Frustum Culling. Wait, what happened? Yo, thank you, Detective Jones. I appreciate it for gifting memberships. Like, Detective Jones has like gifted so many memberships, man. Like, thank you, I appreciate it. But please take a break, Detective Jones. Oh wait, it's your birthday today, right, Detective Jones? It's 5th of July. It's your birthday, right? It's your birthday. Yes. Yeah. Here is Detective Jones' cake. This is for Detective Jones' birthday. Okay, chat, we managed. Yeah, I appreciate it, Detective Jones. I appreciate it a lot. We managed to double the FPS with barely implementing Frustum Culling. It's not finished Frustum Culling. We can optimize it even more. We are just using one plane, and there are 1, 2, 3, 4, 5. There are 6 planes that we are not using. We are just using one plane. There are 6 planes in total. So we can get even more boost in FPS. Even bigger boost in FPS we can get. Maybe we can utilize every core to optimize performance. Oh yeah, and if we use multi-threading, if we have multi-threading, we can have crazy boost in FPS with the TNTs. Because we try here, if we do 1000 TNT, here 1000 TNT, the game crashes when we do 1000 TNT. Bro, the culling is too good. It's too good. But if we break it, and it crashes the game. So we need multi-threading to fix this. Maybe we're going in some kind of an endless while loop. I'm not quite sure. Let me close it because we crashed it. Let's open it again. And where is chat? Sub chat. This is OpenGL. Everything but redstone. Can you work on multi-threading? That depends on chat. No notification. Oh, bro, sorry man. No notification. July 4th. Twitch ping. Late notification. Yeah, I don't know. Sometimes the bot doesn't give the notification. I don't know why the bot doesn't give notifications sometimes. This is very cool though. I remember last time. OpenGL can have multi-threading, but you need to make sure you're rendering on the same thread you created the OpenGL context. That's the only thing you need to be sure of. Like, you cannot draw triangles from multiple threads. It needs to happen from one thread, but on a separate thread, you can do other stuff, like generating the mesh. You can have multi-threading in OpenGL, but you need to be careful. This is very cool. I remember last time it was barely anything. Synchronization for the course would be really hard for TNT. Hey, what's up? What's up? Have you used Sea Lion? PC specs, I've showed it many times already. Summarize the stream and let know what the in a moment. What is good idea for Python? Okay. So basically the summary is we are adding Frustum culling, and it's working too good actually. Look at this. It's not. Basically, what we're doing now is we are not rendering the subchunks behind us. And right now, by mistake, it's taking too many of them. Look at how these ones on the corners, we're not rendering them, but they are visible. And I think it's because, no, it's because of the subchunk origin. The subchunk origin is not in the center. It's like in the corner. And so here, probably, we're not looking at the corner of the subchunk. Yeah, look at this. Yeah, once the corner of the subchunk is outside, we're not drawing it. We should probably center it, the origin of the subchunk. When we give it, we should probably center it. And it will fix it. But basically, our game was with 100 FPS. Right around there, and now it's almost 300 FPS by using Frustum culling. So basically we are not rendering the chunks behind us, and we're not even fully utilizing Frustum culling. What do I mean? We're using just one plane here, the near plane. So basically we're doing a check to see if for example a chunk is behind this near plane. But that's not completely correct, because the subchunk can be here, it can be here, and it's not visible. It should be here. Everything here is visible from the camera. Everything here. And so when we are just using this near plane, if a subchunk is here, we are still rendering it, and it's not visible. Yo, welcome, man. Thank you, man. I appreciate it, Will. Thank you, man. Thank you. Appreciate it, man. I appreciate it. You guys make like all of this possible, man. Like every viewer watching, every viewer becoming member, all of you guys make this possible, man. Thank you, guys. Thank you, guys. Well, we'll make Minecraft too, but we need to make a lot of changes. We need to change textures, and we need to change models. We need to change animations. We need to change the whole game. So basically we're not doing Minecraft too. But at least we're doing fun streams. I like the streams. At least the streams are fun. Yeah, look at this. This is the Frustum culling. We need to make it so it doesn't. We need this to not be happening. Let's move the origin of the subchunk, because let's say it's like somewhere here, the origin. Like let's say it's somewhere here, the origin. And once we're not looking at it, we're not drawing it. We need to center it to here. And so now it should still be visible. And right around here, it will not be visible. Or we can add a buffer. So basically, to add some distance behind us. Yeah, that's what we can do. Yeah, we can add some distance behind us, because here we directly use the camera position here. Camera position. Let's add some distance between us. Let's add some distance. This is the camera forward. And here we use the camera position. How can we add some distance, chat? How can we add distance? What did I miss? If it's... Oh, yeah, we can do this as well, maybe. Nearly enough. Think you need to check for all the corners. Oh, to check for all the corners. Yeah. Let's check for all the corners. Is he checking the center of the chunk or the corners? I'm checking one corner. Corners will work, but has an edge case. Do it if at least one corner is visible. Draw it. Okay. We'll do that. Okay, we'll go over all of the corners. I'm right now implementing TNT, but it's a Minecraft server, not its own game, because it hardest part right now is pushing entities. Just change their velocity. Just change the entity velocity. And that's how you push it. That's how you push it. Okay, let's make it so like we don't ignore subchunks. Let's make it so we don't ignore subchunks that should be visible. And let's do it by going over the four... Wait, is it 4 corners? It's actually... Isn't it like 8 corners of the subchunk? Isn't it 8 corners? Here, 8 corners. Like this. And this. This. This is one big subchunk. This is one subchunk. Isn't it like 8 corners? Yeah, 8 corners. So isn't it like 1, 2, 3, 4, 5, 6, 7, 8? Isn't it 8 corners? Why only 4? Why only 4? Or maybe just the 4 top ones to check. Because right now we're checking just one corner. We're just checking one corner. Wait, not this chat, this chat. Checking all corners is a good idea. 8, yes, might be too many chunks though. The problem with checking all corners, if the chunk is very large, could see if line intersects with plane. That's like 128 checks per chunk. Yeah, because one chunk has like 16 subchunks, and so it's like 8 times 16. Unless you share the checks like some said, Jake. Yeah, Jake is smart. But if we're looking from below... Oh, if we're looking from below, it will still work. Like we're using the camera. We're using the camera Frustum, it will still work. Let's do just the top 4. Let's just do the top 4 temporarily. Let's do the top 4. And let's make this into a separate function. Here, auto is point visible. Is point visible. Let's make it into a function. Make it into a function. And here we need to get... What are we getting? Vector 3 const reference. This is the point. And here return if this, and here we need a reference A, B, C, and D. And here let's change this to point. Okay, perfect. If all of this is greater than 0, this is when the point is visible. And so here we delete this. Or greater than or equal than. Greater or equal than. And here we do is point visible. And here we do the position. Okay, now it should be the same like before. Let's test it. If it's the same like before, we'll check the 4 points of a subchunk. Yeah, let's wait to see if the FPS improves after the terrain generates, because everything is on the main thread. The problem with checking all corners, chunk is very large. Yeah, we read that. You could do many less, like 16 only be determined and rounding it. If you are in the center of the chunk and look directly down, then there will be no corners of the chunk visible. Oh, so, but if we add the center, it will be visible. If we check 4 A's down instead of 8 points, not sure. So do you think maybe one chunk buffer is a good idea? 4-point chunk into multi-threading, mainly always render the chunk you're in. Ah, yeah, yeah. We got how much FPS? Yeah, 260, 240 by using the function. Maybe it's a bit less FPS when using the function. Okay, let's use the other points as well. Here, this is 1 point. How are we going to do it? Here, boolean is chunk, subchunk visible equals false by default. And so if just 1 point is true, is visible, then we'll leave it like that. So how are we going to do it? If yeah, okay, we can do it. We can do it here. Is subchunk visible equals if is point visible position, or if is point visible, or, and then we need to do this multiple times. We need to do this multiple times, like 1, 2, 2 more times, like this, 2 more times. So what are the other 3 points of the subchunk? How to get them? Well, they're at plus 16 on the X and Z plus 16. So here, position plus 16 on the X, vector 3, and here position plus 16 on the Z. This is vector 3, and here the last one, position plus 0, 16 on X and 16 on Z, and this is vector 3. Okay, and if the subchunk is subchunk visible, that's when we draw it. But no, we can do one big improvement here. We do this check as well, because it could be empty, it could not have a model. Let's do this before all of this calculation here, and here it will be continue like this, and here this is second like this, and here like this. No, this like this. Perfect. And sadly we do the same separately for drawing the semi-transparent ones, because we enable color blending then. Let me think about it. Okay, let's leave it like that. Let's test it. Now everything should be rendered. We shouldn't have subchunks that are invisible, which should be visible. Let's wait for the terrain to generate. But yeah, now it's perfect actually. Look at it, everything is drawing. Everything is getting rendered. Now we need to see if we still get the FPS boost. We need to see if we still get the FPS boost. Maybe always render the chunk you are in. Yeah, we already read that. Do it in collision checking in your existing code. You are in Phoenix video, I just noticed. I only found you through your streams a few weeks ago. Yeah, I know I'm in Phoenix video, but that was like 8 months ago. Like it was more than half a year ago when Phoenix made a video. And he made a video on my Java clone. This is my new one, the C++ clone. 10 times is position visible. Try stand near the edge of a chunk and look at point where there is no corner. That video 8 months ago. Yeah. Okay, how much FPS do we get? How much FPS do we get? 200. 230. 230. So a bit lower FPS than before. We got like 260, 270. Now we are 230. It's still fine. It's still fine. And we're seeing everything. Okay, I don't know where the borders of a chunk is. I'm not sure. But we're drawing everything, kind of. We're drawing everything. The only problem is the generation, the world generation, because it's on the main thread and it has lag spikes. And because it's on the main thread, I am doing the generation in multiple frames. That's how I do it instead of multi-threading. But it still has lag spikes. But that's a separate issue. That's a separate issue. But once everything gets generated, we get 200 FPS for now. How to get on Discord? Connect your Discord with YouTube, and that has your YouTube account, and you'll get it automatically. Connect it to YouTube, your Discord. It should have integrations with every social media place. You can do it with Twitch as well. You have 3D clouds. I have 3D clouds in the Java clone. Now the other planes, yes. Can you add debug print to see how many chunks you're skipping, total chunks? We could do that actually. That's a good idea. Think your old math plus with render the 8 chunks around the chunk we're in is more optimized? No. It was just not render while you were above it. The water is semi-transparent chunks. It's different. We need... I'm drawing it separately. How many hours has it taken to do this so far? I think it was like 5 or 6 weeks. It won't be perfect. The points overlap, so we are checking the same point 8 times. What do you mean the points overlap? Ah, yeah, for the semi-transparent. Yeah, that's right. But that's for some other time to figure out. So we got like 200 FPS, like 230. We got 230 FPS just using this plane from the Frustum, just using this plane. But we're not using the other ones. We're not using the other ones, which will improve our FPS even more, even more. And we have like 45 minutes free time, so we can do it. We can see what else we can do with Frustum culling. So we could, for example, use this plane, the far plane. I think this is a good improvement. But somebody asked like, how long have we been working on this project? And all of the whole project has been streamed. So we can look at the first stream. And it was kind of a recent one. It was here, this one month ago. This is when we started. This was on 17th of May. This is when we started. This is when we started. Yeah, this was the clone back then. 17th of May. Yeah, here, look at this. This was the clone back then. And here we have plus channel. We should have Clay as well. Clay was here as well. Yeah, this was like 17th of May. So how long ago? 17th of May, then 17th of June, and we're close to 2 months. We're close to 2 months. Close to 2 months of progress. And now we're here. Now we're here. Now we're here, guys. So let's say 2 months of progress. 2 months. And here, look at how the water disappears. It's because we're doing it separately, the semi-transparent ones. We should work on them as well. But this is like between 1 and 2 months of work. Oh yeah, we have the player. I forgot we had the player. Yeah, we have the player and we have the bunny hop. And we have the particles. We have the TNT. We have the TNT. We have animations. We have structures. Yeah, the structure block. We have structures. Here. And here we can load. What can we load? Oak tree. We can load the oak tree. Oh no, let's load our first house before we continue with the Frustum culling. First house. Let's load the first house. And here we have structures. So when I hit load and I move away and it needs to regenerate here. This is the first house and we loaded it with this block here with the block structures. This is the first house and that's how we load these ones as well. We load these ones as structures. And yeah, this is our village. And what else? Kind of fluids, but they don't flow. Here this disappears because semi-transparent ones, we need to fix the Frustum culling for them. We draw them separately. We have the portal. Here we have the portal. Oh, it's in the opposite side, like this. Portal. This is the portal. Yeah, but this is for about 1 and 2 months. Yeah, but let's continue with Frustum culling because we have 230 FPS, somewhere around there, 220, let's say. We can improve it even more by using, instead of just using the near plane, we can also use the far plane here. We can use the far plane as well. I'll read chat and then we'll use the far plane as well in the time we have. How much FPS was it without rendering anything? 1000. It was 1000 FPS without anything. And so we got 200 out of 1000, the maximum. If optimizing other things by profiling would get... Yeah, if we... One option for chat for today was to add a profiler. Like in-game profiler. Like sure, we can use third-party profilers, but it would be interesting to have in-game profiling as well. Don't even what email, my YouTube's connected to it, so right, maybe you can member all manually. I'll try to do it manually, but try to do it yourself because it's automated. Like I don't know if I can do it manually. Try to connect it with your account, but I'll try to do it manually as well. You could do hierarchy, like first check entire chunk, then sub chunks. Oh, you're right, bro. You're a genius. We can get the whole chunk. No. Because I'm not sure about that. I'm not sure about that. Plus one sub, bro. You're a genius. Thank you, man. It's really amazing. Oh, this is just Minecraft. I joined when you made something in desert biome. Interesting. So the point at the center of a 4 chunks is recalculated 4 times. Point at the center of a chunk. We are not calculating the center of a chunk. We're calculating the corners. It will improve performance a bit. It's fine. It's fine. Our focus is the Frustum culling. It's fine. Maybe for particles, you should sample only a random part of a texture. Yeah, we'll do that. But we had a 3 hours limit. We just had 3 hours limit. I wanna call it like you in future, man. Thank you. With fire, please. Good. Please make mobs. That depends on what viewers vote for. We can't first check the full chunk because 9 out of 10 times the top and bottom points are... Yeah. If you check the entire chunk, the corners will be miles up. Yeah. You'll need to check a point by modifying the Y value. Camera up and position. I love your streams. Keep it up, bro. Thank you, man. How do people get started with programming? You just start. In the beginning it's difficult because it's like you cannot do much, but the more you invest, the more fun it gets. Especially if you avoid tutorials. Like, try to avoid tutorials. Like, do them at a certain point and then stop and try to do your own project. Because after following a tutorial and then you're like, okay, I forgot the whole tutorial, now what? And you feel bad about it, like as if you cannot learn. Just do projects. Result point is visible. It approaches 0 as the point nears the edge, becomes negative out screen, so maybe we can check if small, not just 0 for a buffer. At the center of 4 chunks, I mean the corner that connects the 4 chunks. I don't get it. I don't know if learning JavaScript is good start. Just start. Don't worry about it. Don't worry about it. You can always switch. Like I switched from Java to C++. Can you please quickly show state of the project as of now? I just joined. This is the good part of YouTube. You can go back in the stream because we need to move on. We need to move on. If you check, yeah, we need to move on. Yeah, let's move on. Let's move on. So we got about 220 FPS from one. We doubled the FPS. We doubled the FPS, but we can increase it even more by adding this other plane, this plane as well, because we are just using this plane. We're just using this plane. How are we going to get the far plane? Because for this one we used the camera position. Maybe we need to. Yeah, where we define the camera. Let's see where we define the camera. Let's see where we define the camera. I think when we define the perspective, that's when we wrote it down. The distance. Where is it? Here. Camera, player camera. Perspective. Target. Up, FOV. And what about the distance between the near and far plane? What about that? How can I get that? If we can get the distance between this plane and this plane, we'll be good. We'll be good. Say Frustum culling in title. Okay. Frustum culling. Frustum culling. Sure. And let's update the... I'll start this game in the background and we'll come back to it just for a screenshot. But let's go back to here. Okay. How can I get the distance between these two? How can I get it? Like in my Java clone, the distance was about 1000. Okay, let's pick any distance. Let's pick like a distance of 500. It doesn't matter. It's fine. Let's just pick any kind of distance. It's fine. Let's pick any kind of distance. We can change it later. We can change it later. And maybe we should just use 1 point, chat. Maybe we should use just 1 point of the subchunk, the center. And maybe to add some kind of a buffer. So that we don't need to check for each subchunk 4 or 8 points. Yeah, let's just use the center of the subchunk. I think that would be a lot better. Let's just use the center of the subchunk and we'll figure it out with some kind of a buffer. We'll figure it out later. Yeah, let's go to the subchunk. Where is subchunk? Here. And where do we use this? Final references. No, we'll not get a helpful reference. Let's go in game layer here. Where did we draw? Here, yeah. No. Here, yeah, here. Yeah, this part. Let's just check for 1 point. We don't need to check for all of the points. We'll do it differently. Because this is just checking in terms of one plane. Just the near plane. We need to do it for like 6 planes. And if we do it for 8 points, times 6 planes, times 16, that's for a single chunk. It will be too many checks. Do you have finished games somewhere, like small games or something? I want to check out. No, it's just... I don't have any published games. Oh, everything I do is not published. Yeah, let's just check for 1 point here. Let's open the drawing here. Let's say this is the subchunk. A subchunk is 16 by 16 by 16. We checked this, and this corner if it's after this plane. Now we'll just check 1 point. And we'll check if it's after this plane and before this one. Let's do that. And let's say this plane is at a distance of 500 of this one or 1000, doesn't matter. We'll figure it out. Yeah, let's do that. Here, but let's open up back the game and let's see the FPS. It's around 220, I think. But it depends where we look at. Yeah, 220. I don't want to include the RAM because like people will be like, bro, your project is 1 gigabyte. Okay, let's include the RAM. Let's be transparent. Let's include the RAM. And let's update the thumbnail. Change. It's barely visible. But it's fine. It's fine, chat. Okay. Yeah, let's use just 1 point here. Let's just use 1 point instead of the 4 points on the top. Here, just 1 point, like this. Let's just use 1 point, and we'll use the far plane as well. But let's see just the near plane. Let's just see the near plane. If everything... Oh, we need to change it. Yeah, look at this. We need to change it because now we are hiding some subchunks by mistake. Yeah, here, look at this. We're hiding them. We need to use the center point. Here we do plus vector 3 16 16 16. Oh no, actually it's 8 plus 8 plus 8. 8 plus 8 plus 8. Let's do that. Okay, now it's good enough. We can see here at the back yeah, like this. Yeah, look at this. Until we get to the center, these ones are not rendering. Down here. It's... bro. Yeah, we need to add some kind of a buffer. like distance. Let's add a distance. So let's go a bit behind us. Let's just move the camera a bit behind by using the camera forward. So yeah, let's do it like this. A vector 3 near plane position equals camera position, and then we need to add to it how much. Like we need to move it backwards, so the inverse of the camera forward. So let's subtract camera forward. Let's just subtract the camera forward and let's see what the result is. Maybe a bit better. If let's scale it a bit more here. Vector 3 scale. Let's scale it a bit by a big number 5, just to be sure it's doing what it's supposed to. Yeah, now it's fine. Now it's fine. Kinda. Oh no, it's not fine. It's not fine. Oh. Maybe to be then plus. Oh, we're not using it. We're not using it, bro. We're not using it. We're not using it here. Near plane position, near plane position, near plane position. Jake, I saw your suggestion. I just want to check this out. My approach. If my approach doesn't work, I'll look at your suggestion. Yeah, now everything is included. No. Bro, what? We are under the terrain. We're under the terrain. No. It's fine. Yeah, it's fine. If we go backward. It's fine. Yeah, we moved the near plane a bit. What happened here? Oh. What happens here? So what happens here? Or maybe to, well, let's increase it to see what we get, and let's multiply by 10. We're playing around with the near plane position. It's working. I was AFK. Oh, now we moved the near plane a lot further. We moved it a lot further. Like this. And yeah, look at this. This is the Frustum. Yeah, we moved the near plane a bit. Yeah, let's move it again back, but by 10. Yeah, let's move it back. Oh, by 16. Because that's the dimension of a subchunk. We can move it by 16. But here it's fine. It's fine. By 10, it's fine. Or like half. No, let's do like half a subchunk. So 8. 8 should be enough. We're moving the near distance, near plane position by 8 backward. And now we can. Okay, it's perfect. Is it? Yeah, here. Here was the issue. Just in a certain direction. Okay, let's do 16 then. Let's do 10. If 10 doesn't work, we'll do 16, which should for sure work. Because the dimension is like 16 by 16. Let's see, do we get anything missing? Do we get any subchunk not rendering? Everything should render now. Yeah, everything seems to render. Yeah, everything is rendering. And we'll wait to see if once terrain generates, to see if the FPS is above 200. Just to see if we still get the improvement. And then we'll add the far plane as well. We have 30 minutes to add the far plane. Remind me of PlayStation 1. Like all Minecraft that have random chunk gaps every so well. What do you like more for game development? C++? I like Java because I like C++ because it doesn't have a garbage collector. Why the limits, by the way? What do you mean limits? So that I don't I was going to say so I don't brain rot. So I don't burn out. So I don't burn out. So that I can do it every day. Like I do streams every day. So look at the chat. We have 250 FPS. We have 250 FPS. So it's working. The Frustum Culling is working. Even when the distance, even when the, and look at it like this. Look at this chat. We get like 400 FPS. Look at this, 600, 700, 900. Look at this, 900 FPS. That's because we are not looking at the terrain. We are not drawing anything. Look at this, chat. We're not drawing anything. And once we look down below, we are drawing a lot. And the FPS tanks. But we're just using the near plane of the Frustum camera Frustum. We need to use the far plane as well. Yo, this is very cool, man. Thank you, chat, for suggesting Frustum Culling. That was very cool. Let's commit this and add the far plane as well. And let's actually use it here as well. Question mark? Yeah. Let's use it here as well. For the semi-transparent ones. So what now? Yeah, let's commit this. Frustum Culling with near plane. And let's add the far plane as well. So we're doing it with this plane. Let's do it with this plane as well. Which shouldn't be that hard, actually. It shouldn't be that hard. So basically we just need to change this value. So here, let's just input it here. Load D. Or maybe like to give here the position. Yeah, vector3 position. And here we calculate the position. Everything else. Position. What's the matter here? Oh, I didn't type it right. Position. Perfect. And here we are checking. Bro. Wait a minute. The naming is not right. The plane position. This is the... Let's rename it. Plane position. Which will not be accurate later on. It will not be accurate. Probably. So here we are using the... This is the subchunk origin. This is subchunk or center. Subchunk center, and here we use the near plane position. Okay. Near plane position, and here we need or if is point visible to, or and if the point is visible, the subchunk center to the far plane position, like this. Far plane position. Let's calculate the far plane. Oh, but what about the normal? The normal is different. Yeah, we need the normal as well here. Plain normal. Because it's different, I think. It's the opposite. Vector 3. Plain normal. And here... this is plain normal X. This is plain normal Y. This is plain normal Z. Like this. Perfect. And here we don't need this. We don't need this. Here let's save it as vector 3 near plane normal equals the camera forward. Equals the camera forward. And here let's use it. Here, let's use it here. Let's use it here. Yeah, this is the plain normal, like this. Okay, let's use it. Let's use it. So here we need, this is the near plane normal, like this. Near plane normal. Near plane normal. Oh, wait a minute. But it will calculate it every time. Unnecessarily. Yeah, we don't need to do it like that. It will every time, for every subchunk, it will calculate the same thing. Are you checking the air sub? No, I'm not. We're ignoring the air subchunks. You need a button to freeze the Frustum so we can see what is drawing. That's a good idea. Oh, bro, Jake, you're a smart man. Like, how are you so smart, man? That's very creative of you. That's a good idea. Here, Jake, W Jake. This tree is basically W Jake. Bro, Jake. It's also... This is generally saying skill. Bro, holy cow. After you finish this, what will you do with it? What do you mean after I finish this? When is the finish line? Did you know that it's plain, not plain, right? Bro, I'm not going to change it now. We'll leave it as that. We'll leave it like that. Won't it be less efficient to calculate ABC each time if your inputs are all? Yeah. His can't be that smart. Yeah, this is, we're doing it a bit bad. Like, we're doing calculations too many times. Let's temporarily comment this out to run it to see if this tanks the FPS a lot. Having it here. I need to give it here as well. Yank inside this. What happened? And we do it here. And this is the subchunk center. And we do it for the semi-transparent ones as well. So we do it 2 times. How is it? Is it still fine? Will it tank the FPS that much? I'm not sure. We need to see. It will just make your CPU work overtime for no apparent reason. Yeah, but if it's not that bad, we'll move on. I want to see how much it tanks the FPS. Like doing the same calculation unnecessarily. If it tanks it too much, I'll improve it. But if it doesn't tank it, if it's above, if it's 210 FPS, it's fine. If it's 210. But we need to see. We need to see after the terrain generates. Because everything is on a single thread. Okay, 230. Okay, it's fine. It's fine. Like it tanked the FPS from 250 to 230. We lost 20 FPS. We lost 20 FPS, kinda. But let's test it out. Let's test it out. Now, if you always make it like that for any input, it would be definitely change a bit. 20 is huge though. Yeah, it's fine, guys. It's fine. I'll test it out off stream, removing them to not calculate them unnecessarily. But here I want to focus on the far plane. That's for me more interesting. And is point visible the subchunk center to the far plane. Okay, so it's plane. Yeah, plane. What's the difference? Plane. Oh, it's actual like plane and plane. Math. Yeah. Oh, yeah. Okay, I'm typing it wrong. Sorry, guys. So it should be far plane. Was this the position? Position and far plane normal, like this. So let's calculate these ones. Let's calculate them. Camera forward. Okay, okay, let's calculate this. So, how do we calculate them? The position. Okay, let's use the, let's add just the, to the camera position, let's add the camera forward 500 times. Or like 50 times. Let's do 50 times. And here, this will be vector 3 scale of the camera forward by -1. By -1 and done. That should be it. And let's rename them. This is far plane position, far plane normal, like this. And I did only 50 just to test if it's working. If it's working. Let's test it out. Let's see if the far plane is activated. Okay, look at this, guys. We're ignoring, like here for the water example. Look at how the water is still rendering because we're doing it separately. Like the water is drawn separately. We're ignoring the water. But look at how we're filtering out these subchunks here. We're filtering them out. That's pretty cool. Okay, let's increase the distance even more to 500. Let's say, like we can dynamically increase it. Actually, we can dynamically increase it. We can dynamically change the far plane distance, I think. Oh, look at this 500 FPS. 500. But the far plane is pretty close. Far plane is pretty close. Let's increase the far plane. Let's increase it to 500. Let's try 500. Let's do 500. Do we see the fog? We need to see the fog. If we're seeing the fog, it should be fine. Maybe. Maybe. I'm not sure how to be sure. I'm not sure how to be sure, yeah. Let's wait the terrain to generate to see if there's any difference to the FPS. Like we may have even lowered it. To even performance, it should add mods and to sodium if you want. Won't the far plane always be further than the render distance? To cull more chunks to the... what if we look down, Jake? What if the player looks down? What if the player... Bro, we lowered the FPS with the far plane, with the extra calculations. We lowered the FPS. Wait, no, yeah, okay. We may need to remove the far plane. We may need to remove it. Bro. Yeah, let's remove the far plane. Let's remove it. Let me think about it. What about the other planes from the Frustum? What about the other planes? Like the top one? Top one is fine. This one, the right and the left one. The right and the left one. Oh, and this bottom one. That would be very... Oh, the bottom one is very useful actually. Because we will not see the caves. The caves are very annoying. It will be a big boost in FPS if we have the bottom plane. Wait, the bottom plane normal is the camera up. It's the camera up here. It's the camera up. And what's the position? The position... I'm not sure how to calculate the position of the... How to get a point from the bottom plane. How to get a point from the bottom plane. I need a single point from the bottom plane. I need a single point. I'm not sure how to get it. How to get a point from here? Let's search again. Raylib camera Frustum. This is much harder to get since it depends on the FOV now. Oh, it depends on the FOV. Imagine the clone would be multiplayer. That would be funny. Let's see how we can get the camera Frustum. How we can get the camera Frustum. Was this example? Do we have Frustum? No. Let's open Raylib GitHub. Let's open the GitHub because there's a lot of examples here, and let's search Frustum. Let's search Frustum. Oh, bro, look at this. RL Frustum. And but it just takes left, right, bottom, top, Z near, Z far. Oh, and how is this used? Matrix Frustum. Get perspective projection matrix. Calculate projection matrix from perspective instead of Frustum. What's this? What's this? Okay, this is the only thing we get about Frustum. Okay, let's search for RL Frustum. Let's search for that in the code. Let's search for RL Frustum. Here, this thing. What's this? Begin mode 3D. Oh, so this is where they create the... Like this is where they use the camera. Z near and Z far values are important when computing depth buffer values. Top. Get cull distance near... Oh, here they use the camera FOV. Times 0.5 degree to radian. And right. Oh, here, look at this. Right, top. Also, yeah, bottom and top. So this is the bottom, this is the top. And this is distance near and this is distance far. Interesting. This is for perspective. Yo, I think we can use this. What's this? Setup camera view. Matrix look at camera position, camera target, camera up. And what's this? Enable depth test. Here, what do we do? Okay, let's see this function. What is this function? What do they do? Current matrix. So they create a matrix with it. They just set up here the value. They manually create a matrix here using these values. Multiply the current matrix by a perspective matrix generated by parameters. Hello, using like human channel. Human channel. Top arrow, get call distance near top times the aspect. What's the aspect? Sure. Draw render batch active. Matrix mode. Push matrix load identity. These are just values. These are just values. And here we have a matrix. Here we just have a matrix. Is there... when Jake is saying something, everybody listens. Aspect is the aspect ratio of the screen. It's not interesting. Here, let's look at learn OpenGL for Frustum culling. Let's just look at it for a bit to see if there's something about a matrix like this. Because here I see a bottom and top. And I see a Z near and Z far. Like Z near and Z far, we don't need them. But the bottom and top, I think this is of big interest. Let's see if they mention anything about a matrix like this. Let's see if they mention something. Learn OpenGL. And here Frustum culling. Let's see if they mention something about that. And we'll just quickly look at it because we just have 4 minutes, chat. We'll quickly look at it. What's this? Oh, look at it. This is Frustum culling. I should have just shown you this, guys. Like, this is what we're doing. Here the red is what's not being rendered. Look at how it's not drawing all of the trees. Look at how we're rendering only some of the trees. Yeah, this is the Frustum culling. Yeah, this is what we implemented, but not fully. Not fully. But we got close enough. We got close enough. Oh, they represent a plane in the same way. They also use a normal distance from origin to nearest point in the plane. We don't use this. We can create Frustum structure and has a top, bottom, right, left, far, and near. Interesting. And create Frustum from camera. Oh, bro, look at this, look at this. This is exactly what we need. Like here, near. Look at the near face. This is what we did. Let's see how do they do it. Here they do camera position plus the Z near times camera front. Yeah, that's the position. And the camera front, this is the normal, the camera front. Let's see what do they do for the bottom face, and we can do the same. Okay, they use just the position, and for the normal, bro, but we can just use the camera up. We can just use the camera up. Here for top face, what do they do for the far face? They use the camera position plus front multiplied by the far. Yeah, okay. Okay, so it's very easy. Yeah, okay. Yeah, it's very easy. Let's bring the code how it was like just with the near plane. The most optimized version. Let's bring it back. Is it only in the commit? Yeah, we just need to undo the commit, I think. I think we just need to undo the commit. Yeah, let's undo this commit. Let's discard changes. Okay, let's see. Did we discard too much? Here, where is the Frustum? No Frustum. Hopefully I didn't delete everything. Yeah, here. Yes. And this. Okay, yeah. Perfect. Okay, chat. Let's open up the Minecraft. And let's wait for the terrain to generate. Yeah. Chat. What's up? Hello. Okay, so chat today voted to add Frustum Culling, and here it's a very useful GIF on what Frustum Culling is. This is a video from Learn OpenGL, and here you can look at on the left. This is just a map filled with just trees. Here we're rendering a bunch of trees, and you can see here with the yellow is what the camera sees, and with the red is outside of the camera. And basically here, as a result, we're just not rendering what's in the red. And by doing that, you get a boost of FPS. Because here, we can do the same in Minecraft. Here in Minecraft, if we look at the whole, like look at this. If we look at just one chunk, which is like this, we get like 700 FPS. We get a lot of FPS. And if we look from above, the FPS tanks to about 100. Because we are seeing everything, and now we need to render everything. This is Frustum Culling. It makes it so you render only what the camera sees. And the more you render, the more the FPS tanks. And this is what we implemented today. So basically we started with about 100 FPS, and now we are at around 200. So we doubled the FPS. We doubled it. But once we start moving, the terrain generation tanks the FPS because everything is on the main thread. And we implemented Frustum Culling by using the camera Frustum here. This is the camera Frustum, and we are just using this near plane. If we start using the other planes, we'll get much better FPS boost. But we don't have the time for that since we have a 3-hour limit. But I found a very good article on Frustum Culling, and I saw here how they get the near plane. And we need to get the other planes. And here they tell you how to get them. So basically I just need to do what they do here. And we'll be able to do the same for the other planes. This will give an even better boost in FPS. An even better one. But the absolute maximum is like 1000 when I don't render everything. So if we want the most improvement, I need to use a profiler to see where we're losing FPS. Where we're losing. But that's like what we managed to achieve today. Look at this, like 200, we doubled the FPS. That's what we did. We doubled the FPS when we're not moving. If we add multi-threading, it will stay as 200. And if we do other optimizations, we'll get even more FPS. But it's just not optimized right now. It's just not optimized. Bro. Yeah. Well, you should learn coding. Did you get inspiration from... I don't know what that is. Yeah. Yeah. So my limit is 3 hours. The stream adding the profile would be a good one for performance. Yeah, and big W for Jake. Jake carried the entire stream. So big thank you to Jake, man. Like, he was a big help. How did you fix the bug where you couldn't replace terrain with the path yesterday? I just, it was a one-liner. I just had a stupid mistake in the code. It was a one-liner change. It's not something interesting. 3 hours limit is so I don't burn out. Yo, what's up, Creeper? Yeah, guys, that was it. And so, bye, guys. It was fun today. And I'll see you guys tomorrow.